Here are our two linear inequalities. X minus y is greater than 3, and then I gave you this ordered pair, 2, negative 1. Remember, this is your x, this is your y. Then here's the other one. 2x plus y is less than or equal to 10. 5 is your x, 0 is your y. So now in order to determine, remember, determine makes a decision. We're going to determine if this ordered pair does fall into the solution set, whatever that solution set may be. So all we have to do is substitute these two numbers in place of our x and our y, and we're going to work it out and say, okay, is the left side true compared to the right side? So let's do that. We have 2 minus the y value is negative 1, greater than 3. So when I do that, what do I notice here? I notice that I have what? Double negatives. We don't like double negatives, do we? So let's get rid of that. So when I get rid of that, I have now, I'm going to write it up here, 2 plus 1 is greater than 3. So now when I'm going to work this out, I have 2 plus 1, which is actually 3. 3 is greater than 3. Well, you might say, okay, well, hey, I got a 3 on one side, a 3 on the other side, I'm okay. But there's a problem. And the problem is the sign. The sign says greater than. Can the number 3 be greater than itself? Can the number be less than itself? The answer is no. It can be equal to itself, but it cannot be greater than or less than itself. So when you have a situation like this and you don't have that equal to sign underneath your greater than or less than, this is not in the solution set, so you would say no. That ordered pair is not part of my solution, okay? Now let's try the bottom one and see what happens with that. So our bottom one, we have x is 5, y is 0, so we have 2 times 5 plus 0 less than or equal to 10. So evaluating order of operations, it says multiplication comes first, so that would mean 10 plus 0 less than or equal to 10. Well, any number plus 0, that's the addition property. So that means, boom, 10 is less than or equal to 10. And notice on this one, it has the equal to sign under it. See, because it has this equal to sign under it, you can say, yes, this ordered pair does fall into the solution set. So up here, because it was missing that little line that said equal to, we had to say, no, it doesn't really work. Here, it had the equal to sign, so we could say, yes, that one does actually work for this problem, okay? All right, so that's all for determining. That was fairly easy. Now we're going to work on actually graphing and then shading greater than and less than on these lines, okay? So I'll see you back in a minute.